Okay, so here is warm-up 10.5. I've got some inscribed angles here. None of these are central angles. So the common mistake on, I've got these numbered wrong, but on this first problem, which I have numbered as number 2, people will say, okay, here is arc DF. Well, 72 degrees, so 72 degrees, oops, that's incorrect. If that were a central angle with the vertex at the center, that would be true. But when it's an inscribed angle, you'd want to double the 72. So I'm going to actually get 144 degrees here. So the measure of arc DF would be 144 degrees. Okay. All right. Same kind of deal. So I double this angle to get the intercepted arc here, and 40 degrees is the intercepted arc. So let's just call this x. I would double x. So I can write 2 times x equals 40 degrees, and then I just take half of it. Or you can just think about dividing the 40 by 2. That works. That's really what I'm doing here, right? I just wrote a little equation. So this is going to be 20 degrees then. Okay. All right, so let's find ST. So this one's a little different because ST, arc ST, is this piece of the crust of the pizza, right? And I don't have the arc that goes with that. I have the arc, I don't have the angle that goes with that arc. I have this angle, that angle goes with this arc. So what I can do here, though, is say, okay, this is going to be 2 times 61 degrees, which would be 182 degrees. 122 degrees. Wow. Okay. Must be tired. All right. 122 degrees is that green arc. Okay. So now I'm kind of stuck. But wait a second. This green line here is a diameter, right? So that means it divides the circle in half. So that means what I just shaded is 180 degrees worth of circle, but also this is 180 degrees worth of circle. And that's going to allow me to solve for that little missing bit, right? So now I can say the measure of arc ST plus 122 degrees is going to equal 180 degrees. And I just have to do a little subtraction then. And I'm going to get 58 degrees then for the measure of this arc. Okay. All right. And last but not least, I've got an inscribed quadrilateral here. So all 4 vertices are on the circle. I've got a quadrilateral that fits perfectly inside of a circle. Okay. So I'm going to explain, there's a pretty easy way to solve this problem, but I want to try to explain why this works. So if I think of this inscribed angle, I would double that angle to get the arc that goes with it, right? So that means all of this would be 2x. Okay, and I can do the same thing if I go across the circle to the 70 degrees. So 70 times 2 would be 140. Okay, now if you look at both those arcs together it makes up the whole circle. So I can then say, okay, 2x plus 140 is going to equal 360 degrees. It's the whole circle. Okay. Now let's just, as a little experiment, let's divide everything in half here. I could solve this without dividing everything in half, but I want to do this because if you look at the original problem now, well, x and 70, these are 2 angles that are across from each other, and they're going to be supplementary. It always works out like that, okay? So you can just remember that if you've got an inscribed quadrilateral, just add the opposite angles and they'll be supplementary. Okay, so then I've got x equals 110. And if you remember that little property, then you don't really even have to write an equation using or even think about the pink and the green angles like I was. But these 2 are also across from each other, so they're going to be supplementary in the same kind of way. So I can also say y plus 113 is going to equal 180. And then just a little subtraction gets me where I need to go. So that's going to be 67, right? Y is 67 degrees. And that's the end of the warm-up, and I'll see you next time.